Okay, this is Chemistry Podcast 2.5, and we are going to talk all about the periodic table. So, back in 1869, that was the first periodic table, and it was by Dmitri Mendeleev. What he did was he arranged the elements by increasing atomic mass, and he also grouped them into columns based on similar properties. So everybody in group 1 here reacted the same. Everybody in group 2 acted the same. Everybody in group 3 acted the same. And he noticed that every 8th element, the properties would start over and repeat themselves. He was so confident in this periodic table that he actually left spaces where he believed elements should be, but he thought they just hadn't found them yet. So you can see one here, here, and here. And he was correct to do that. In his lifetime, 3 elements were found and placed exactly where he predicted on the periodic table. Today, our periodic table looks a little different because we don't order by atomic mass, we order by atomic number, and that's due to Henry Moseley, who found the proton. So some common vocabulary that you need to know. Rows on the periodic table, they go horizontally. There's 7 of them if you were to number them down. Each one is called a period. These right here are called the intertransition metals. They actually fit in up in the 6th and 7th row. So they did this in order to make the periodic table more compact and not quite so long. So these belong to row 6 and row 7. The columns on the periodic table run vertically, and we call them groups or families. And that should make sense because groups and families tend to act the same, as do the elements in the same column. The properties of these elements are the same because they have the same number of valence electrons. Everybody in the first column has 1 valence electron. Everybody in the second column has 2 valence electrons. And that's why they have similar properties. So the first periodic table we're going to do, and this should be in the worksheet packet that you have. If you want to stop and color code this first before going on, we're going to talk about the 3 classifications, the 3 big ones, which are metals, nonmetals, and metalloids. So the metals I made red, and you can tell that takes up most of the table. Our metalloids are right here, and if we were to look, there is a really dark line. It's called the zigzag line, the stair-step line. It runs down like this. That's a terrible line, but that's where it goes. So you can see that the metalloids fall on either side of that darkened line. And then you have the nonmetals over here. Our only exception is hydrogen, who hangs out over in this family because hydrogen has 1 valence electron just like everybody else in column 1A. But make sure you get this color coded before we go on. The next thing is properties of metals. On the back of that periodic table that you just colored, you can write down some properties of metals. And we'll do properties of metals, metalloids, and nonmetals. So properties of metals, they're shiny, they're really good conductors of heat and electricity. That's why we use them for wiring, because they conduct that electricity. They have really high densities, they have higher melting points, so it's not really easy to melt a metal, and you know that probably from personal experience. Ductile, that means you can draw them into thin wires, and malleable means you can hammer them into thin sheets. These are 2 vocab words that you need to make sure that you know the definition of. Properties of nonmetals. Nonmetals are the opposite of metals. So they're dull, they're not shiny, they're not good conductors of heat and electricity. We call that an insulator. They're brittle, so they break really easy. Instead of being solids at room temperature, most gases are, or most nonmetals are gases at room temperature. And then they tend to gain electrons during bonding. So the metals would lose electrons, and then nonmetals like to gain electrons during bonding. And we see a lot of compounds that are formed between metals and nonmetals. Okay, metalloids fall right on that stair-step line that splits the nonmetals from the metals. They contain properties of both. It can go either way. They can be less malleable than a metal, but they're less brittle than a nonmetal. One really important property of a metalloid is that they can be semiconductors. And your semiconductors are used in technology a lot to make those little computer chips. So metalloids are really important in industrial settings because of the properties that they contain. Okay, here's the next periodic table, and this is where we're going to talk about the different families or groups, the columns on the periodic table. So stop for a second and color code yours so that it matches mine. Okay, the alkali metals are the first family we're going to talk about. They are in column 1A on the periodic table. It's everybody except hydrogen. Hydrogen's not included because hydrogen's not a metal, although it acts like the alkali metals. All these guys have one valence electron, and it's a lot easier to give their one away than it is to gain 7 more. So if they give their one electron away, that means they have a +1 charge. They are soft, silvery white, and shiny, which you can see in the pictures over here. And that may seem surprising to you because they are metals and they're soft, but it's true. You can dig into them and dent them really easy. They're almost like a putty, so they're very soft. They bond very easily with lots of things. They hate water. They will react with the water that even is in the air. So when we are storing these, we have to store them in oil so that they don't react with the water in the air. Because they're so reactive, we never find them uncombined with something in nature. And then as you go down the column, they get more and more reactive. The alkaline earth metals are in column 2A. They have 2 valence electrons, and they would like to give their 2 valence electrons away, so they form a +2 charge. They're not quite as reactive as the alkali metals that we just talked about, but they are still reactive enough that you never find them pure in nature. They're always found in combination with something else. And just like the alkali metals, they're going to get more reactive as you go down the column. The transition metals are that big group of metals in the middle of the periodic table, and we call those the group B elements sometimes. They all have properties that are really similar, and they're also very well-known elements and ones that we use a lot. So if you think of iron, mercury, we don't use a whole lot, it's just really cool. Titanium, platinum, gold, silver, copper, all of those are transition metals, so they're kind of your everyday metals. They're really good conductors. Most of them have 1 or 2 valence electrons, which means they're going to lose them. There are exceptions to that rule though. They can have 3 or 4, some of them can go up to 6 or 7 valence electrons. The halogens are over there in the non-metal area of the periodic table. They're in group 7A. They have 7 valence electrons, so they want to pick up 1 more, which means they form a -1 charge. They are the most active non-metals. So the alkali metals, they were the most reactive of the metal families over there in 1A. These guys are the most reactive non-metals, and they do the opposite. They are the more reactive at the top, which means fluorine is the most reactive non-metal on the periodic table. And we'll talk about why that is when we get in periodic trends. These guys really react easily with the alkali metals. If you recall, we say that these guys want to lose 1 electron. Well, these want to gain that 1 electron. So if you think of sodium chloride, sodium has 1 valence electron, chlorine has 7. They just do a little switcheroo like that, and they form a ton of compounds really easily. Many of these are poisonous, and they're so reactive we don't find them free in nature. So here's examples of chlorine gas, bromine, and iodine. The last group are the noble gases. They are in column 8A. They're clear on the right-hand side of the periodic table. They all have 8 valence electrons, with the exception of helium, which only has 2 valence electrons. They do not gain or lose any electrons because they are stable with what they have. They have a full outer shell, They are all non-reactive, and the other word that you hear a lot with them is that they are inert. Inert just means non-reactive. And if you look, here is a picture of all the different gases. So you think of neon signs. Well, this is the colors that you would see. These are called gas discharge tubes. So what we do is we just run a current through there, and it makes the gas, the helium gas or the neon gas or whatever it is, light up so we can see what colors it emits. Okay, that is the end of podcast 2.5. Make sure that you have both your periodic tables color-coded and that you wrote down a lot of the information that you saw from this podcast so that you can save it in your notes for future reference.